Hovering on the icy outskirts of the solar system is a strange blue-green world that rolls along on its side, shrouded in frigid methane clouds and encircled by enigmatic rings. This peculiar planet still holds countless mysteries within its hidden depths. Welcome to Uranus, the sideways seventh planet. Ever since its discovery over 2 centuries ago, this distant ice giant has perplexed astronomers. From its extreme tilt to its lopsided magnetic field, Uranus breaks all the rules. Could this also make it an unexpected oasis for life in the outer solar system? Join us as we plunge into the unknown and explore the strange quirks of this forgotten frozen world. Today, we'll uncover the secrets of Uranus and finally make sense of the solar system's oddest resident. What is this icy giant really made of, and how was it formed? The answers may reveal more than we ever imagined. March 13, 1781, William Herschel was peering out into the night sky with his telescope when he discovered something peculiar, a faint object moving rather slowly compared to brighter stars in the background. Herschel first thought it was a regular comet, but with further investigation and to his surprise, it wasn't. It was a planet. You see, until the late 18th century, astronomers believed there were 6 planets in our solar system. You know which ones, right? Mercury, Venus, Earth, Mars, Jupiter, and Saturn. The 5 that you could see in the night sky were fairly visible under good weather conditions and were mentioned throughout ancient history because of their visibility. However, Herschel stumbled upon something further away, something that hadn't been understood before. Another planet that was part of our celestial neighborhood, a new addition to our solar system. Although, even 240 years after its discovery, Uranus could still be regarded as one of the most mysterious planets in our solar system. Well, mysterious for us at least. That's mostly because the planet hasn't been studied enough. The only space probe to have ever reached the planet is Voyager 2, which came within 50,000 miles or 81,000 kilometers of its icy cloud tops in 1986. The Voyager data is considered gold for studying the planet, largely due to the lack of data available. With its characteristic blue-green hue, Uranus is a visually striking planet. But beyond its glossy veneer lies a dynamic and complex world that remains shrouded in mystery. Uranus falls into a unique planetary category known as an ice giant. Unlike the colossal gas giants, Jupiter and Saturn, which are composed predominantly of hydrogen and helium, over 80% of Uranus's mass consists of heavier volatile ices like water, methane, and ammonia. Uranus is essentially a giant ball of gas and liquid. Like the other big planets made of gas and ice, Uranus is covered in a thick layer of clouds. The reason it appears blue-green is because of the methane in its air. Although this term can be misleading, Uranus falls into a category known as an ice giant. It's a different kind of planet than gas giants like Saturn and Jupiter, or rocky planets like Earth or Mars. Uranus and Neptune are the only 2 planets in our solar system that are in this group. It is also regarded as a planet of intermediate mass. This means it's much heavier than rocky planets like Earth, with about 15 times Earth's mass. However, Uranus is significantly smaller than gas giants such as Jupiter and Saturn, which are over 300 and nearly 100 times more massive than Earth, respectively. This reveals that Uranus must have a vastly different internal structure than both gas giants and terrestrial world. We still don't know exactly what Uranus is made of. To get a better understanding, we need a spacecraft to visit and gather more detailed information. We're currently assuming it's composed of heavier substances than helium. The planet is likely to have a large number of ices, which could be substances like water, ammonia, and methane. It could also contain rocks and a mixture of hydrogen and helium in its gaseous layer. The gas giants Jupiter and Saturn are mostly composed of hydrogen and helium, while the rocky planets like Earth are composed of heavier material. Uranus is somewhere in between. We're uncertain about the balance between the icy and rocky parts of the planet, but there's a chance that it contains rocks like silicates. Uranus's diameter is a bit bigger than Neptune's, approximately 4 times the size of Earth. The density of Uranus is 1.2 grams per cubic centimeter, which makes it the second least dense planet, right after Saturn. For reference, the Earth's density is 5.5 grams per cubic centimeter. This Low density is essentially how scientists figured out that Uranus is mainly composed of different kinds of ices, like water, ammonia, and methane. Beneath its icy blue clouds, Uranus is differentiated into 3 layers. The core of Uranus is small and weighs only about 0.55 times as much as Earth. Its radius is less than 20% of Uranus's overall radius. The icy middle layer, called the mantle, is much bigger, weighing around 13.4 times the mass of Earth. The upper atmosphere is not as heavy, making up only about 0.5 times the mass of the Earth. It stretches over the last 20% of Uranus's radius. The core of Uranus is incredibly dense, reaching a maximum density of around 9 grams per cubic centimeter. The pressure at the core is extremely high, 8 million times the atmospheric pressure on Earth, and the temperature is extremely high, around 5,000 Kelvin. The mantle of Uranus isn't made up of normal ice as we know it, but rather a super hot and dense fluid containing water, ammonia, and other volatile substances. This fluid is very conductive, so it's sometimes called a water-ammonia ocean. The intense pressure and heat deep within Uranus could cause the methane molecules to break apart, with carbon atoms turning into diamond crystals that fall like hailstones through the mantle. This is similar to the idea of diamond rain on other gas giants, such as Jupiter, Saturn, and Neptune, but more on that later. The fluid interior of Uranus prevents it from having a solid surface. Eventually, the gaseous atmosphere will transition into the liquid layers below. The surface of Uranus's atmosphere is often referred to as its surface because the pressure is equal to 1 bar, similar to Earth's atmospheric pressure. For convenience, this is used as a reference point for height measurement. This surface has equatorial and polar radii of about 25,559 and 24,973 kilometers, respectively. Uranus and Neptune are different from Jupiter and Saturn in terms of their bulk composition. They are called ice giants because the ice materials dominate over the gases in their structure. The water molecules might even split into hydrogen and oxygen ions, and even deeper down, there might be a form of water where the oxygen forms crystals and the hydrogen ions can move freely. While this 3-layer model is considered likely, the precise composition and internal structure remain unknown without more detailed spacecraft observation. But one thing is certain: Uranus still holds many mysteries waiting to be uncovered about ice giant planets, and more missions to this distant world will help shed light on its concealed depth. One unique aspect of Uranus is its extreme tilt. Unlike the other planets in our solar system, it appears to be rotating on its side as it orbits the Sun. The tilt was likely caused by a collision with a large celestial object early in the planet's history. Scientists determined in 2018 that the world that collided might have been twice the size of Earth. This tilt causes very unusual seasons that last for around 20 years each. This means that for about a quarter of Uranus's year, the Sun directly illuminates one pole, while the other hemisphere has a long, dark, and freezing winter. Even though Uranus is not the farthest from the Sun, it has the chilliest atmosphere among all of the planets in our solar system. The reason for it is that Uranus lacks sufficient internal warmth to counterbalance the solar warmth it received. Uranus completes one rotation in 17 hours, and its orbit around the Sun takes 84 Earth years. Uranus is also one of just 2 planets that rotate in a retrograde direction, the opposite direction of most of the planets. Venus is the other one. The magnetic field of Uranus is also tilted, at an angle of 60 degrees from the planet's rotation axis. This makes the magnetic field uneven, with the northern hemisphere having a field strength 10 times greater than the southern hemisphere. The lopsided magnetic field may cause Uranus to turn its magnetosphere on and off each time it rotates. Prior to Voyager 2's visit in 1986, scientists were baffled about the nature of Uranus's magnetosphere due to a lack of measurements. At first, they thought that Uranus's magnetic field would match the solar wind, which should have matched the orientation of its poles in the ecliptic plane. But Voyager discovered that Uranus has a special magnetic field. From Voyager 2 data from 2017, it appears that this asymmetry causes Uranus's magnetosphere to interact with the solar wind, exposing the planet to solar particles. This is different from Earth, whose magnetic field is roughly balanced at its poles and equator. The magnetic field of Uranus is 50 times stronger than Earth's. Neptune also has a magnetic field that is moved and tilted, which might be a common thing for ice giants. One theory suggests that ice giants generate their magnetic fields due to motion at shallower depths, like in a water-ammonia ocean, unlike terrestrial and gas giants, which form deep within their core. The magnetic field alignment could be influenced by oceans of liquid diamonds within Uranus. Uranus also exhibits highly developed aurorae around its magnetic poles, in contrast to Jupiter's, although they do not play a significant role in its thermosphere's energy balance. In 2020, NASA said that they had found a large atmospheric magnetic bubble, or plasmoid, that had been released into space from Uranus. This made them look at the data from Voyager 2's 1986 flyby again. Essentially, it's a giant magnetic bubble that may have been whisking Uranus's atmosphere out into space. According to NASA, these giant bubbles of plasma, or electrified gas, pinch off from the end of a planet's magnetotail, the part of its magnetic field blown back by the sun, like a windsock. With enough time, escaping plasmoids can drain the ions from a planet's atmosphere, fundamentally changing its composition. This, too, has been deemed a mystery, and it is actively being studied further. Uranus's significant tilt results in unique weather patterns. NASA's observations indicate that when sunlight finally reaches certain areas, it warms the atmosphere, which leads to big springtime storms. However, during Voyager 2's initial imaging of Uranus in 1986 during its southern summer, the spacecraft captured an unremarkable-looking sphere with only around 10 visible clouds. This resulted in the planet being humorously dubbed the most boring planet. Uranus' true nature was revealed later thanks to advanced telescopes like Hubble, which revealed the planet's dramatic weather changes as its long seasons unfolded. In 2014, astronomers finally observed summer storms raging on Uranus. Interestingly, these massive storms appeared 7 years after the planet's closest approach to the Sun. It is still a mystery why such significant storms happened when the Sun's influence on the planet should have been at its peak. Remember we mentioned something about diamonds raining down? Well, another peculiar phenomenon on Uranus is the concept of diamond rain. This unusual occurrence is thought to happen deep inside giant planets like Uranus and Neptune. It is believed that intense heat and pressure are responsible for the compression of carbon and hydrogen, resulting in the formation of diamonds within their atmosphere. These diamond particles then sink downwards over time, eventually accumulating around the planet's cores. It is believed that diamond raindrops on Uranus are predicted to be as large as millions of carats. Uranus is unique among the planets in that it seems to have reached a point of thermal balance with the Sun. There are two possible explanations for its cold surface appearance. One is that its interior could be hot, but this heat might be trapped inside, preventing it from dissipating. This would mean that while the planet is hot on the inside, its exterior remains cold. Another possibility is that Uranus might have lost its original heat slowly, maybe because of a big impact or some other unknown process. In short, we don't understand why Uranus looks cold. This is one of the most important mysteries about the planet. During its 1986 flyby, Voyager 2 only saw a few clouds, a great dark spot, and a smaller dark spot on Uranus. More recent observations have shown that Uranus' atmosphere displays dynamic clouds as it approaches the equinox, including rapidly changing bright features. The overall atmospheric conditions on Uranus are frigid, with a minimum temperature of -224.2 degrees Celsius, making it even colder than Neptune in certain areas. The wind speeds on Uranus can reach a remarkable 560 miles per hour, or 900 kilometers per hour. Talk about windy days. These winds have a retrograde pattern at the equator, blowing in the opposite direction of the planet's rotation. There is a prograde flow as one moves closer to the poles, matching Uranus' own rotation. In simple terms, the winds of Uranus change direction depending on where you are. They go against the planet's rotation at the equator and match it at the poles. The rings of Uranus were the first to be seen after Saturn's. They were a big discovery because they helped astronomers understand that rings are a common feature of planets and not just a feature of Saturn. The Hubble Space Telescope discovered the outer ring system, which features two more distant rings with vibrant hues, one red and one blue, whereas the inner ring system consists mainly of narrow, dark rings. Researchers have discovered 13 known rings around the planet. Several studies have suggested that the rings of Uranus, Saturn, and Neptune may be the remnants of Pluto-like dwarf planets that once strayed too close to the giant worlds. These dwarf planets were ripped apart by the immense gravitational forces of the planet. The rings around Uranus are made up of very dark particles that come in all sizes, from minimal to just a fraction of a meter. Almost all of Uranus's rings are incredibly narrow, only a few kilometers wide. These rings are probably relatively young since they likely did not form at the same time as Uranus itself. According to scientists, high-speed collisions may have broken apart a moon to form these rings from the remains. Only a few pieces of debris created by these collisions were able to survive and settle into stable zones where the rings are now located. Back in 1789, William Herschel suggested that Uranus might have a ring around it. However, this idea was met with doubt because the rings are faint and other observers in the following 2 centuries didn't report seeing them. However, Herschel provided a detailed description of the size of the epsilon ring, its angle relative to Earth, its red color, and the way it appeared to change as Uranus moved around the Sun. They later found 4 more rings. Voyager 2 confirmed the presence of these rings when it flew past Uranus in 1986. It also discovered 2 additional faint rings, bringing the total to 11. Then, in December 2005, the Hubble Space Telescope found 2 more rings that were previously unknown. The larger of the 2 is situated twice as far away from Uranus as the other 2 rings we already know about. These new rings are so far away from Uranus that they are called the outer ring system. Hubble also found 2 small moons, one of which, called Mab, is in the same orbit as the outermost, newly discovered ring. The total number of rings around Uranus increased to 13 with these new findings. The colors of these new rings were determined by images from the Keck Observatory in 2006. The blue ring at the outermost end and the red ring at the innermost end. The blue color of the outer ring could be caused by tiny particles of water ice from Mab's surface that scatter blue light. In contrast, the inner rings of Uranus appear gray. Speaking of Mab, I think this Uranus moon is a good segue to what we're about to talk about next. Uranus boasts a total of 27 moons that are currently known. The names of these moons aren't the usual ones, based on the mythologies of the ancient Greek or Roman world. The initial 4 moons were given names derived from mystical entities in English literature, such as William Shakespeare's A Midsummer Night's Dream and Alexander Pope's The Rape of the Lock. Astronomers continue to choose moon names from Shakespeare's or Pope's works to name the moons. The 2 largest moons of Uranus are Oberon and Titania, which were both discovered by Herschel in 1787. The discovery of Uranus' next 2 moons, Ariel and Umbriel, was made by William Lassell, who was renowned for being the first to identify a moon orbiting Neptune. Almost a century later, in 1948, Gerard Kuiper, famous for his work on the Kuiper Belt, spotted Miranda. In 1986, Voyager 2 flew by the Uranian system and found 10 more moons. These moons are named Juliet, Puck, Cordelia, Ophelia, Bianca, Desdemona, Portia, Rosalind, Cressida, and Belinda. They are 16 to 96 miles, or 26 to 154 kilometers, in diameter. These moons are composed of approximately equal parts water, ice, and rock. Following Voyager 2's visit, astronomers employed the Hubble Space Telescope and ground-based observatories to increase the number of known Uranian moons to 27. The task of identifying these moons proved challenging, with their small dimensions ranging from 8 to 10 miles, or 13 to 16 kilometers in diameter. Moreover, their black appearance, resembling that of asphalt, and their considerable distance from Earth of nearly 3 billion miles, or 4.8 billion kilometers, further complicated the process of detection. Located between the moons Cordelia, Ophelia, and Miranda, a cluster of 8 small satellites, is located between the moons. Scientists are still puzzled by how these moons have avoided collisions. Anomalies observed within Uranus's rings have led researchers to speculate about the existence of even more moons. Moreover, in addition to its moons, Uranus could potentially host a collection of Trojan asteroids. These objects have the same orbital path as the planet and live in a special region called a Lagrange point. The first of these Trojans was found in 2013, even though some people had thought that Uranus' Lagrange point might be too unstable to hold such celestial bodies. Voyager 2, launched in 1977, had its closest encounter with Uranus on January 24, 1986. It came within 81,500 kilometers, or 50,600 miles, of the cloud tops on Uranus before it continued its journey to Neptune. During this period, the spacecraft studied Uranus in various ways. Voyager 2 looked at the composition and structure of Uranus's atmosphere to find out more. The study centered on the peculiar weather patterns of the planet, which are influenced by its extreme tilt and what makes Uranus look like it's rolling on its side. Besides providing the first detailed observations of the 5 largest moons of Uranus, it also discovered 10 new moons. It looked at all 9 rings around Uranus and found 2 more that were not known before. Voyager 2 wasn't just interested in the planet itself, though. It also examined Uranus's magnetic field, which turned out to be quite peculiar. The magnetic field's shape and tilt were different from what scientists expected. Overall, Voyager 2's encounter with Uranus provided a wealth of new information about the planet's atmosphere, moons, rings, and magnetic field, helping scientists understand this distant world better. Since then, no other spacecraft has passed by Uranus, but there have been a lot of ideas for new missions to study Uranus again. One suggestion was to send the Cassini spacecraft from Saturn to Uranus, but this plan was rejected because it would have taken about 20 years to reach Uranus after leaving Saturn. Instead, Cassini was intentionally destroyed in Saturn's atmosphere. We have a detailed video of the entire journey of the Cassini-Huygens spacecraft, which you should consider watching. We'll have a link in the description below. Another idea is to send a probe into Uranus's atmosphere. The design of this probe could be similar to the Pioneer Venus multiprobe, which was used to study Venus. This probe could reach a depth of between 1 and 5 atmospheres on Uranus. Another possibility is to send a spacecraft to orbit Uranus and possibly even land a probe on its surface. A group of scientists recommended this idea in a report called the 2013-2020 Two Planetary Science Decadal Survey, published in 2011. According to this plan, the spacecraft could launch between 2020 and 2023 and take about 13 years to reach Uranus. The report suggested this because we are still not familiar with ice giants like Uranus. When another group of experts reaffirmed that sending a mission to Uranus should be a top priority in 2022, this idea gained even more importance. This type of mission could provide us with valuable knowledge because we have a lot to learn about ice giants. With all the research being conducted on Uranus and its moons, it's highly likely that a mission will be planned sooner rather than later. Uranus is an intriguing planet that is surrounded by numerous mystery. Its peculiar multiple magnetic field alone is deserving of future missions and research. I think I speak for all of us when I say I am really curious and would love to know more about what Uranus is actually made of, its internal structure, and how it was formed. Was it formed near where we see it today, or did it form elsewhere in the solar system and migrate to its current location? Presently, there are more questions than answers surrounding Uranus, and they are all somewhat interconnected. The world is an unexplored one that is not well understood. It's safe to say that it's time to give it more attention. So, what do you think? What is Uranus really made of? How did it form? And when will we get to know more? Let us know in the comments below. If you enjoyed this video, do drop a like and remember to subscribe. This video is part of a series we're doing on our solar system's planets, which you should definitely check out. And as always, thanks for watching.